Okay. All right. Now, what I'm going to try to show you is actually very important. So what I want you to do is delete this and add and tap to the input and tap it over here. So now what you have is basically you can see the input and you can actually see the output, and now run. And I want you to see this important plot. And I will spend a minute talking about this plot before we go any further. So this yellow is the input. And what you have here, you don't see the plot. Okay. Now you should be seeing the plot. So what you should be seeing is you should be seeing the input and you should be seeing the system response. Now, what happens if I change the frequency of input? So initially, what I'm going to do is I'm going to change this frequency to 0.1. And then I'm going to run this. And look at the plot. Can you see that? So maybe stop time is say 100. That will give you a decent plot. So can you see that this is what we are seeing? So your input is shown in the yellow line and your output is shown in the blue line. Now, what I want you to do is I want you to change this frequency to 0.5 and say run again and click here. Now you would see the response something like this. I want you to change this input to say maybe 2 and run, and then plot this again and see what happens. And then if you continue, the point that I'm trying to say here is as the frequency is changing, the system response is changing. So if you look at this transfer function, the numerator is 1, you have 5 s square plus 10, which is the denominator. And then as the frequency of input is changing, the system output is changing. Everyone understood this? This is an important concept. Now I want to give you a simple example. I think most of us do our own laundry. So can you, when you actually try to wash your clothes and you run in a spin cycle, you probably observe this. When the washer is spinning at a slow speed, it's not vibrating a lot. As the spin speed increases at certain frequency, the washer would start vibrating violently. And then after some time, it dampens down. So what it means is very important. The response of the system is dependent on the frequency of the input. Once again, the response of the system is dependent on the frequency of input. If the input frequency matches the natural frequency of system, if the input frequency matches the natural frequency of the system response becomes infinite, because that is what is called as resonance. At resonance, there is a free transfer of energy from the external input, the system. So if there is no damping, if external damping is 0, the system would start vibrating violently. And to investigate this type of phenomenon, what we do is we construct something called as uh, uh, the root locus or the body diagram. So that way we understand how the system is going, behavior is going to change either with respect to parameters or with respect to external excitation. And we will talk about those concepts in future classes. In the next class, we will talk about those. But what I want to show you here is this block is called as the transfer function. And the transfer function can be used to solve a differential equation in Laplace transform. MATLAB is an excellent tool for doing that. Now, let me give you some hints on transfer function. Why is this concept of transfer function and everything important? So why is this concept of transfer function important? So usually we engineers want to describe this mathematical models as some sort of a block. So this is a block. And this block has a transfer function g of s. And if this block is connected to another block, this is g of s, say g2 of s. So think about g1 of s, g1s is a system, g2s is another system, and these two systems are combined together. So what you can do is you can combine these two blocks and actually construct a big block, something like G1s multiplied by G2s. Yes?
So this may sound like a silly question, but why multiply the two blocks and not add them together?
Okay, the reason for that is basically the output of this block. So this is the block. Okay, let me answer this question. So you have an input. So I'm going to call this maybe x of s. This input get fed to this block. What happens to this input over here? It becomes x of s times g1 s. This whole thing becomes input for the second block. So what happens here? You have x of s g1s multiplied by g2s. So this is actually same as x of s multiplied to g1s times g2s. So what is the application of this? So you have a robot subsystem and you have another subsystem. So what you can do is you can actually combine the transfer functions and write down a straight transfer function. The concept of transfer function is also very important when you are trying to design the control systems. So there are two types of control systems. There are two types of control systems. One is called as the open loop control. So what you have is you have a system, you have some control input that gets fed to the system and you have output. So think about if I'm teaching you without any feedback from you. I don't see whether you are responding, whether you are understanding. So that is like going in an open loop. The other approach is closed loop. In closed loop, what you have is you actually take sample from the output and actually combine this with the input. So basically what you have is you have something called as the feedback. And this could be a transfer function. This could be a transfer function. So here you have an output, you have an input, and in an open loop system, there is no feedback coming from output. In the closed loop system, you have feedback coming from the output. And then what you do is you basically, to give you an example, look at the 3D printers that you have. Those 3D printers have stepper motors. Stepper motors don't have any sort of feedback mechanism. So basically you send a step command, the stepper motor would step through that command. But if you were to use the DC motor with some sort of feedback that I talked about in last class, like an encoder, optical encoder, Hall effect encoder, or resolver, or any other feedback, you can actually see what command you gave and what was the response of the motor. So that for some reason, if there are atmospheric disturbances, if there are friction changes, if there is something that went wrong, you can correct it inside your controller module. So there is an open loop system and there is a closed loop system, and transfer functions can be used to design so closed loop systems. You can actually use transfer functions to analyze the robotic systems. Actually, I would like to take an example, but I don't have enough time. So what I'm going to do here is I'm going to stop, but I would be happy to answer any questions related to the project or the robot or the assignment that you may have. Next class, what I will do is I would give you some discussion on controls, and then remaining part of the class, I would solve the assignment 5, problem number 1. But if you have any questions, I would be happy to answer. Or by the way, there is no robot. I mean, there is no office hours tonight. But if you want to talk, I'm here for 5-10 minutes more. So you're welcome to ask me any questions.